The prehistoric world is a landscape defined by towering flora and unstable ground. Navigating this environment requires a guide, which is why we're following our explorers, Neo and his daddy, into a particularly treacherous stretch of swamp. They've arrived just as a crisis unfolds. 10 different dinosaurs are packed together, sinking into a massive mud pit that threatens to swallow them entirely. The initial instinct for these animals is to use raw strength. A Triceratops tries to wedge itself free with its horns, while an Ankylosaurus thrashes its heavy tail. But the mud is too thick. It simply absorbs the impact of their specialized weapons. As more dinosaurs rush in to help, the danger compounds. By adding their own immense weight to the unstable ground, they break through the surface and become trapped themselves. In this environment, high body mass is a liability. The situation only changes when a young T-Rex stops pulling and starts digging. By using its legs to displace the dirt and create a trench, it breaks the mud suction. This systematic approach frees the entire group where physical pulling failed. Success in this world depends on more than just being the largest creature in the swamp. It requires the ability to look at a physical obstacle and determine which specific trait, like a T-Rex's powerful legs, is the right tool to solve the problem. Every dinosaur begins with a biological blueprint. They hatch from these eggs already equipped with a specific set of physical features designed to help them conquer their particular habitat. This skeletal diagram shows how the Brachiosaurus's cervical vertebrae act as a crane for high-altitude foliage. The Ankylosaurus uses its dense tailbone and pendulum physics to break physical barriers. The pterosaur's wingspan and hollow bones allow it to scan vast areas from above. These specialized features are not random. They are evolved responses to the specific challenges of the prehistoric environment, providing each species with the exact tools they need to survive. Maintaining these massive bodies and specialized tools requires an incredible amount of energy. To understand how they stay powered, we have to look at their different fuel systems. Carnivores, like the T-Rex, require high-density energy to power their massive muscles. They get this fuel exclusively from meat, providing the concentrated calories needed for a predatory lifestyle. Large herbivores, like the Brachiosaurus, take a different approach. To maintain its colossal size, it must graze almost constantly, processing vast quantities of plants and fruits to keep its energy levels stable. Then there are omnivores, like Neo. By eating both plants and meat, they have the advantage of being able to find fuel in almost any environment, making them highly adaptable explorers. A dinosaur's diet is the engine behind its anatomy. The food they eat directly powers the specialized tools they use to navigate and survive. The environment is just as dangerous for the small as it is for the large. 10 baby dinosaurs have become separated from their mother, and they are now wandering alone through the swamp. To find their family, we have to look closely at the babies themselves. By analyzing their physical traits, we can match them to the correct adult. On our taxonomic tree, we check the Pachycephalosaurus. Lacking domed skulls, the connection fails. They also lack traits to swim or fly, ruling out Spinosaurus and Pterosaur. This leaves their large feet and sharp teeth, leading directly to the T-Rex, a perfect match. As the babies reunite with the adult T-Rex, the traits we identified are easy to see. The same massive feet and sharp teeth that define the mother are present in her offspring, ensuring they have the protection they need to grow. The prehistoric world is filled with a vast diversity of tools, sizes, and diets. But despite all these differences, these creatures are all linked by the protective bond of family.